Okay, so here's our replacement video for those 2 pages that were left out of the last one. And again, I apologize for that. So this page is about the different steps of the scientific method and kind of what it is. The scientific method includes critical thinking, which is observing all parts before and during drawing a conclusion. So critical thinking is where you have to really kind of look at the different pieces and try to figure out what's going on, and you have to think about it really logically. A hypothesis is an educated guess about the outcome of an investigation, and it is testable. To be logical means it is expected to happen. So when you're doing an experiment, you should get logical results, results that match your hypothesis or are something similar that kind of makes sense. An explanation would be part of your conclusion, which is a reason, a cause, or an answer. So your conclusion is going to include information of why your results happened, like why you got the results you did. When you're doing your experiment, you'll need to record the data, so you need to write the data down. And you can do this in charts, graphs, tables, with notes, with pie charts, etc. There's several options. Data are pieces of information. So that's the measurement or the numbers or the observations that you're going to get when you're doing your experiment. And a critique is to identify the problems and successes with an investigation. And at the end of your investigation or your experiment, you're going to do that to your own project. You're going to write down what mistakes you made or what you could have done better, or maybe what things you would try next time. But other scientists will also do this to each other. So if somebody else does an experiment, I will look at it, look at all the information and their conclusion, and then kind of talk about, what they kind of could have done better or what mistakes they might have made. And here's kind of the process. And so what I like about this one is that it shows that the process can kind of go back and forth, and it doesn't necessarily have to go in a straight line every single time. So the first thing is that you're going to make observations. So where it says start here, number 1, observe. So you're going to look around your world and you're going to see what you're interested in. You're going to find out what you're curious about. The best experiments come from things you're really interested in, not just from things that you pick because it sounds complicated or fancy. Number 2, you're going to ask a well-defined question. It needs to be testable, something you could actually do an experiment on. It cannot be based on opinion. So if your question is, which is better, cats or dogs, that's an opinion. So that's not going to be a good testable question. It needs to be specific, so we know exactly what we're looking for. And it needs to be based on one independent variable to keep us focused on that one question. Number 3, then you're going to write a testable hypothesis. It needs to answer your question directly. It needs to be in an if-then statement. So if I change this about the independent variable, then this will happen to the dependent variable. Number 4, you're going to make a plan, and that's the details of the test. And that's when you're going to write down your materials and your procedure, like the stuff you're going to use to do your experiment, and then the steps you'll take to actually do the experiment. And again, with number 4, with the plan, if you think you're going to use a certain material and you end up not using it, or you end up using something else, you can go back and change the materials list, or if you need to change a procedure, like you forgot a step, you can go back and add it afterwards. Number 5 is the actual test. It's the experiment. So that's when you're actually going to do whatever steps you have decided on. Number 6, you're going to evaluate, interpret, and analyze. So you're going to look at your data and you're going to figure out what it's telling you. Are there patterns? Are most of the numbers, kind of in the same ballpark? Like everything's about, 1 meter tall, and then one other child is maybe like 6 meters tall. And you want to figure out why is that one child so different? You're going to look at your numbers, you're going to look at your data, kind of see what it's telling you. And then number 7 is where you're going to do the critique. So you're going to write down a conclusion, which is a logical explanation. So it's an explanation or a reason why you got the results you did, and it's based on facts that you got in step 6. This is also where you're going to put down what you could have done better, what improvements you could make, maybe what other questions you now have that you're going to look into, and that's going to be your conclusion. If, when you get to your conclusion part, you can't make a logical conclusion, or the information you got does not support your hypothesis, maybe it's the opposite of what you thought was going to happen, then this is where you're going to cut across. That's where we have that oval in the middle. And you can go back and rewrite your hypothesis and try again. And scientists have to do this a lot. Like, they have an idea of what might happen. It doesn't actually go that way. And so then they change their hypothesis, try again. And then as you go through that process, you're going to get closer and closer to figuring out what's going on. So sometimes you may go through the process once and it works wonderfully. Sometimes you may have to go through the process several times before you can start to get a conclusion that you can write.